Good afternoon, everyone. Today we're going to continue our discussion on linear regression. So far, what we have been doing is we discussed the assumptions of classical linear regression model. And last time, what we did was to download a data set, the wage data set. Just by way of review, there are many ways to load your data into R, but there are some very important things that you need to do. Primarily, you have to create an R project and then load your data there so that it will be very easy for you to access the data. We used last time the read R package. It has this function read underscore CSV. Then you identify the file name, which can be accessed because it can be found here in the files in your project. So it makes accessing a file, loading a file, a lot easier than if you have stored that data in another location. Then the code here will be quite different. It will have to identify the file location. All right. So aside from, you can actually load it here. If I click this, okay, so you have here import dataset, or you can, it's just the same as this one, import dataset here. Okay, so if I click this import dataset,
You're not sharing screen po.
oh, sorry. Thank you for reminding me. Yeah. Okay, very sorry about that. Okay, so as I was saying, there are several ways to load a data into your R. One of the way is just to write the code. So here we're creating this object wage. We're using read underscore CSV. Okay, as I discussed, kindly make sure that you load the packages that we used. I think we used last time the Pacman package and then loaded the other packages using the pload. So as I discussed, class, kindly load the packages. All right. So in your case, you have already loaded the wage data set. I deleted it for the purpose of having a quick review. So how do you load this? You can click this one, class, here. You have this, what appears in your file section is the data set itself. If I click this, as I said a while ago, you can import the data set, or you can do it here directly, import data set, and you can use the base R package or the read R package. So let me use the more powerful one, the read R, the text. Okay, and it brings us to this. And notice you already have here a code preview, which will be changed as we identify. So because here it's read underscore CSV, it's null because I haven't identified the the data set. If I browse it here and link to or point to the wage data set, and automatically it will open in your R project because I have our project open now. Okay, open, and notice it changed the file name here, wage.csv, and it gave it a default name. The name of the file was given to the name of the object here, wage read underscore CSV. Okay, and then sometimes uh, the package might wrongly guess or determine the nature of the data. As we have discussed before, here it's double. Double is quantitative data, numerical data that can take on decimal places. If it was integer, then it could have reflected this one, integer. Okay. If you change this class, let's say, for example, for purposes of example, I'm going to change, let's say, tenure. This should not be double. This should be, let's say, integer. If I change it here, integer, you know what happens here? It will automatically, it will automatically include that action. If you see the code here, call column types is equal to calls column tenure is equal to column integer. So that was the code. Okay, column types is equal to columns tenure, or you could have used wage dollar tenure is equal to column integer. All right. So notice the any action you do here will automatically, it's like an AI, it will automatically show what the action was here. So let me once again bring this back to double, and notice that it ran the code column calls tenure is equal to column double. So it also recorded that. All right. So next time also, we're going to, we said that for character variable, there's a type of character variable called factor. If I click this into factor, you'll notice that it will also have this dialog box, insert a comma, separated list factors. Okay, so if I just type race, for example, race, okay, and you can of course include gender and civil status, but I won't do that now. If I click this, then what happened here? Okay, it also, okay, inserted this function, race is equal to column factor, levels is equal to race. So that's how we change a particular variable, character variable, into a factor. So let me put it back to character. Okay, so magbabago na naman dito. Okay, so we will go to this later on when we deal with the factors as predictors. All right, so here the name, you can change the name here. You can call it another name, and then first row as names. So that means that you have the first rows are your variables. Okay, delimiter is comma, etc. So once I import this, import automatically, it will write in the console the the code. Okay, the code that I did, read R and then wage. You can see here. Okay, you can see here the code library read R, and then wage is read underscore CSV, the object wage that CSV. Column types is equal to columns of tenure is equal to column double. So here, class, okay, let me just point that out. Okay, column types is equal to, for the columns, tenure is equal to double, for race is equal to character. So it reverted back to the character. Okay, so it recorded everything that we did, and then it included the view wage, which prints the wage data set. Okay, so we now have our wage data set here. So sorry about this, because I reloaded I reloaded R a while ago, so everything that I did before. Okay, so where are we now? We're here. All right, so we have imported the data set. Okay, now also last time what we did was to do some EDA, exploratory data analysis. It's important for you to understand the structure of your data set. In our case, it's our object is wage. So if we get the structure, for example, which we did last time, it will give us some information about our data. So here's the structure. It's a special table here. It's a special table, okay, consisting of 526 rows of observation by 8 columns. Okay, it's a data frame, and you have here $education. We discussed this last time. This is very important. It tells us that education does not appear in your environment. Okay, you take a look at this one. There's no education here. You cannot access education unless you use the $education sign and then affix wage to it. Okay, that way you can, for example, if I want, excuse me, if I want to get the average of education, I cannot do mean of education. I cannot do standard deviation of education. Okay, so for example, mean of education, that's not possible because R will not recognize education. But mean of wage dollar education. If I press dollar, it will give us the elements or the variables that can be found in your dollar tab. Okay, then this will compute the mean or standard deviation or whatever you want measured. Okay, the table function allows us to get the cross tabulation, in particular for character variables, categorical variables. And this is not useful if you're dealing with quantitative variables, especially double. Okay, so let me just run one here. So we have here the table for the civil status, the race, and the gender. So it gives us an idea of the distribution of your data. Okay, there were also other functions that we used last time. For example, the glimpse is just like the structure, and it's also like the summary in a way. Okay. Then we also did other functions like describe, describe by, scheme, which I will not no longer run, class. Kindly review them, and also the desk from the desk tools. Okay, we also learned how to plot the data, and we used here. Will this work, class? Kindly chat, please. If this function plot hourly wage education or hourly wage will work. Will that run, class? This one. Yeah, thank you. Thank you, Diane. Thank you, Kristen. And the rest who answered, Adi, thank you. Okay, it will not run, class, because R will not understand what education is. It does not appear in the list of data that we have loaded so far. So to make this work, you can, several things, you can attach wage. And if we do that, any variable henceforth will be understood by R. Okay, or we can specifically identify where those variables are coming from. Okay, thank you, Adi. Thank you. You're correct. And once again, please share your answer to everyone here. So if I run this, this will work already. Okay, so this is your data for wage and education on the x-axis and hourly wage on the y-axis. And you can see that we were able to solve actually the correlation, right? Correlation between hourly wage, and education, and it's not really that strong. It's only around 0.4. Okay, let's review that. So if we do core of wage, dollar, education, and wage, dollar, hourly wage, their hourly wage, it gives us 0.4, right? 0.4 to 1, which is just a medium measure of correlation between the two. But of all the variables, we said last time that education has the highest correlation with hourly wage. Okay, and we did that actually through the pairs.panels. Okay, what did we say was something that you should be aware of when you're doing pairs.panels or GG pairs? We said that as much as possible, do not include the character variables. Okay, because there is no actually there's no correlation between a character variable and your independent variable or dependent variable. Now why will it generate a value? Because it will automatically convert the values for your categorical variables. It will assign a number, let's say 1 for this particular level, 2 for this particular level. Okay, so that's what happens. So what we did last time was to subset our wage data set. We created this object wage one. Okay. Okay. We were only up to here, right? So, no, here. Did we finish this one, class? Where we create a subset for wage data set? Class? Did you learn how to subset wage? Feedback, please. Did we run this code chunk? Hello, class. Okay, we did. All right. So this one, okay, up until this one. All right. So what we did here was to create this wage one, okay, and then we removed columns 4 to 6. Why did we remove columns 4 to 6? Because columns 4 to 6 are your categorical variables: race, gender, civil status. So what R will do is that generate this object wage one, which contains 1, 2, 3, 4, 5, 6, 7. The variables 1, 2, 3, and then 6, 7. Okay, of course, another way to do this is, okay, let me just comment that out. This can be done also by using C, which is positive combine. So that's 1 up to 3, comma, 5, and sorry, not 5, 7, comma 8, or 7, comma 8. All right. So you get the same answer, class. Wage, combining everything, all the rows are included. And then for the column, you have only columns 1 to 3, comma, 7 to 8, which is just the same as removing 4 to 6. Okay. And then we did this last time, the GG pairs, wage one. Okay, error. Okay, I haven't run wage one. Okay, if I run wage one and then do the GG pairs, so you should have loaded, class. You should have loaded the ggplot2, or you should have loaded tidyverse there. Okay, it's a very good way to depict your data graphically. So this one on the diagonal is your distribution. Okay, this is your the distribution of your data. Above are your correlations, and below is your scatter plot. Okay, so you have here correlation, you have negatives and positives. It tells us of the nature of the relationship. Okay, so may message on dito kay Carlo. Error GG ally not found. Now, what could be the reason? Carlo, could you share your question, please? It's a good question, so that the others will learn from that.
Sir, when I run the whole code chunk, it says object GG ally not found.
Okay, so who among you would like to volunteer an answer to address that, class? If you receive a message GG ally not found, what does that mean? Class, what does that mean? Carlos, paki-share yung yung question mo. Copy it
Oh, okay, sir.
para makita ng iba. Okay, may answer na dito si Michael, and that's correct actually. Yeah, the answer is you're getting that error. It's because it's not yet installed. Okay, so
Oh,
as I
sir,
said a while ago, yes, Carlos.
when I search GG ally in my packages, I already have it installed.
Okay, sige nga, I'll stop sharing. Could you share your screen, please?
Here, sir.
Okay. All right. So GG ally not found. So kindly go to your packet. Hindi pa naka-check, Carlos, no? Ibig sabihin hindi pa siya loaded. Yan. Sige. Okay, so naka-library na siya, di ba? Yan, it's run now.
It still says the error, sir.
Okay, sandali, patingin na. GG ally, GG pairs. Naka-load na yung ano. Error pa rin.
Yes, sir.
Yung ggplot nga, tinan mo. Go to packages and then check if ggplot2 is naka-check naman, no? Sige nga, i-library mo na lang si tidyverse. Let's try tidyverse. Yan, check mo si tidyverse. Yan, okay. So kasama na siya si ano. And then run again. I-X mo muna yung ano. X mo muna yung result. X mo muna siya. Tapos i-run mo lang yung last, yung GG ally. Yan. GG ally not found. Eh, naka-check naman ah. Alright, so tanggalin mo nga yung GG ally. Ah, wait. Isang colon lang kasi, dapat dalawa yan. If you're going to use this namespace, dapat dalawa. Yan, sige, run mo ulit. Yan.
Oh, okay.
Okay, so class, thank you, Carlos, for asking that
Thank you, sir.
question. So ang ano doon, the lesson there is that when you're using the package and you use the double colon, if you want to identify a particular function that's coming from that package. So GG ally and then double colon, GG, what's that? GG pairs, no? Okay, so GG pairs, ito. GG pairs, all right? So double colon siya class, it means that this function comes from this one. If you have installed GG pairs class, actually you don't need that. Okay? Why did I use this class in GG ally? Just for information for your sake. So that you know, GG pairs is coming from that package, GG ally. If I run this, okay, could not find function, bakit? Packages, naran ko na ba yung GGR? Wait, baka ako yung hindi pa ayan, class, take a look at this. Now, it ran a while ago in my case, even if I haven't loaded GG ally, it's because I defined this from GG ally.
Sir,
Okay.
you're not sharing your screen po.
Oh, sorry. Okay, thank you. Okay, what did I do, class? I removed GG ally here. Okay, will this run? All right, I run this GG pairs and then wage one. There was an error. You know why? Because GG ally in my case is not yet installed. It's not yet loaded. So I will have to click this. Okay. Now a while ago it ran. Okay. Let me show you again. GG ally. Okay. Double colon. Will this run, class? Run. Okay. It will run. Okay. It will run even if GG ally is not yet installed. So this is a quirk in R, no? The GG pairs will run even if GG ally is not yet loaded by virtue of this double colon here. Okay, but if I want to remove the double colon, just use GG pairs. I will have to click this. If it's not clicked, as I showed you a while ago, it will not run. But if it's clicked, if we have required it, then it will run. Okay, so it ran. Okay, so take note of that, class. All right, so thank you for your questions. They are very helpful questions, very good questions. All right, so let's now go to regression model. So this is now the start of our regression proper. Now, we said that regression model establishes a relationship between your dependent variable and your independent variable. The objective is, as we showed before, that your y sub I is defined by your slope, intercept plus slope times x2. Let me just use three variables, b3 plus x3 plus a certain error term. Okay, they're equal, class. Okay, your observed value, your actual value is equal to your fitted value, predicted value, plus a certain error term. Okay, because chances are your predicted value will not be the same as your observed or actual value. So in order to make it equal, we interpose the residual, the difference between your predicted, your actual or observed, and your predicted. Okay, if I want to remove this, class, what do I do? If I want to remove the residuals, what do I do, class? Answer, please. We already discussed that several times, class. If I want not to include the
Sir,
residuals. Yes.
y
Sorry.
hat po.
Yeah, correct. Thank you.
Y hat.
Thank you. Yeah, that's correct. We introduced the y hat here. Okay, this means this is also your predicted value. And sometimes you might wish to put that also to mean that these are your computed values also. But do not put on x1 class because these are observed values. Okay. So the function class that we're going to use is this one, LM. This means linear model. So let's try to see. Okay. Let's try to get some information about LM. So let me go here. You can run this class, question mark LM, run, and it will, okay. Okay, why did it, kasi, okay, nag-error siya kasi yung LM ko was close to your code chunk symbol. So let me correct that. Okay, class. So it was close to my LM, so it began reading also this one, the beginning of the code chunk. Okay, there. So no more error here. Okay, and then LM is from the stats package. Now notice we didn't install stats package. It comes preloaded with your R. And what does this do? LM is used to fit linear models, including multivariate ones. It can be used to carry out regression, single straight stratum of analysis of variance, and analysis of covariance, etc. And the syntax for that is this one. Okay, LM formula, then the data subset. So these are parameters which we can insert. Weights, this is for when you have multivariate class and you would like to give weights to your predictors. Right? Method, then you have others here. All right, and then you have an example here. You can run the examples here. For example, this one. Okay, but we will not run this. I'll leave you guys to copy this, copy it, and then copy it in your R. Maybe create another R Markdown or R Studio, R script, and then try that class and try to study it. For our purposes, okay, let's do this. Okay, so I want you to write this class. Create model 1, which means that we're regressing hourly wage on education. Remember, class, that our dependent variable is, our DV is hourly wage. Our IVs are the other variables. So let's first create a simple linear regression. Simple linear regression. For simple linear regression class, of course, we have one dependent variable and one independent variable. So how do we run regression in R? Okay, so take a look at this. We create an object called mod1 or model1, whatever suits you. I just named it mod1. And then here, I'm using LM, and I'm going to define what my dependent variable is, hourly wage, and then use this symbol tilde. Okay, tilde is found in the upper left corner of your keyboard. It's above the tick. Okay, so this is tilde, which means hourly wage associated on education or hourly wage regress on education. This is simple linear regression because we only have one independent variable. If I had, let's say, if I had to use also another one, numdep, then I would just have added it here. So where's numdep? It's also a variable here, numdep. So we can use all the variables as predictors. But let's first start with a simple linear regression. So let's just use educ. Okay, and then we have to define the data. Data is equal to wage. Okay, All right, so kindly run this and tell me what happens to your environment. Let's run first mod 1. And please give me feedback as to what happens to your environment when we run mod 1. What happened,
There's
Crush?
a
Yes.
list of 12 po
Yes.
from mod 1.
So we now have an object here, mod 1. If I run this, control enter, and then automatically you have here mod 1. Now, what type of object is this? What's the structure? It's not a data frame. It's a list. Okay, so I hope you know what a list is. A list is a type of a data structure which can contain several types of data. So it can contain a vector, can contain a matrix, it can contain a data frame, name it, and a list can take that on. All right, if I click this class, what's inside? Okay, so it prints here. It says here in our data that it has 12 elements here. So if we count coefficients, residuals, effects, rank, fitted values, etc., these are the 12 elements inside your mod 1. So here it's a list consisting of 12 elements, a list of length 12. Okay, so what does it contain? It contains the coefficients. If I click this class, oh, you can see here the intercept and the education. So these are the parameters, the intercept and the education. So this is the value of your intercept. This is the value of your education. We can now actually create our model where hourly wage is equal to the intercept plus the slope times education. And then you have here residuals. Okay, how many residuals are you going to get, class? Kindly chat, please, your answer. How many residuals are you going to get? How many? Hello, class. How many? All right. Gab, why 526?
Actually, tinignan ko lang po kasi on the start kasi tapos
Sorry?
it says
Gab, medyo
Ay,
choppy ka.
okay.
Choppy ka. I don't know. Maybe ako lang yun or baka yung iba din. Gab, what did you say? Sige. Okay. You looked under type. What do you mean by type? Here. Okay. All right, 526. But the reason really, class, is that there are 526 observations in your wage, right? Here. How many observations? 526. How many observed values of hourly wage? 526. How many predicted values are we going to generate? 526. Each one of this row of observation will have its own corresponding predicted value. So if there's a predicted value for each observed hourly wage, then there will be also a corresponding residual. Right, class? You got that, class? You got that? So I hope that's clear, class, no? Expect, of course, the number of your observations for your data will be the number also of your residuals. May I have your confirmation, class, if that's clear? Kindly chat yes, class, if you got it, or no, if not, class, and then I'll repeat. Okay. All right. Thank you. Thank you. I'm still waiting for the others to respond. Okay. All right. Thank you. I hope everybody responds to my queries. Okay, back here, class. All right. We'll show in a while how we got these residuals. Okay, and then you have effects, rank. This time are your fitted values. So where did this come from, class? How many fitted values will we get? Fitted values is the same as your predicted values. So once you have your coefficients, class, okay, once we have our coefficients, we can easily compute for our fitted values. How do we do that, class? Okay, fitted values will be just to make sure that you understand this. Okay, we have a model already. Y sub I is equal to, our beta null is, what's our beta null class? I'll just 0.90, right? Plus, what's our slope? 0.54? Is that 0.54 class? And then times education, edu sub I. All right, so this is your observed value, and this is your predicted value. So your observed value is Y sub I. Your predicted value is this one. Okay, so we have education class. For the first value, for the first observation, education is 11. So you're going to substitute 11 here. Okay, and then you perform this equation, you get a value here. So this is your predicted value for the first observation. Then you have your observed value, the actual value. You get the difference of that. Then you get your residual for the first observation. And as I said a while ago, it will be each observation will have its own predicted value or fitted value, and it will have its also it will have its own residual. Okay, is that clear, class? We'll go back to that example and I'll illustrate to you. But is it clear so far, class? Comment, please, class, if we're clear so far. Okay, good. Where did you see the null and the slope? Okay. Are you referring to the intercept? Gab, intercept ba? Dito sa ano? Dito. Ito, nasa coefficient siya. Ito. Diba? Ito let me just close that and then let me open it. Okay. Andito si coefficients. Double siya, ibig sabihin may decimal place yan. Dalawa yung laman niya. And nakalagay dito yung value. Negative 0.905 at saka 0.54. If I click this, it will print here intercept, negative 0.991, education, 0.54. Okay, Gab, did that answer your question? Okay. All right, see, good. Thank you for those questions. Keep them coming in. So how many elements does mod 1 have? 12. 12 elements yan. Okay, let's ask R to spell that out. So we can use the names function. So names mod 1, could you kindly run this, class? Could you run that, please, and tell me what happened? What do you get, class? If you run names and then the object. Hello, class? What do you get? Okay, thank you. Yeah, you're correct. So what's that? What's that, Gab? What are these? The names function will give us, yeah, the names of the object.
Characters.
The names of the object in mod 1. Diba? Ito yung mod 1 class, diba? What's inside mod 1? Yan, coefficients, residuals, effects, rank. And when you run the names, diba, print out niya, it printed out the here, class coefficients, rank, residuals, effects, etc. This is the 10th, yung call, 11, 12. So 12 nga lahat, no? So it just names to us. And this is very helpful, class, kasi, for example, let me just insert this. Okay, so for example, I write mod 1, there, mod 1, and then if I type $, it will give us the element inside your mod 1. So if I type coefficients tab, it will print out this one, the intercept and the education. So that's another way, Gab, to your question a while ago, that's another way to get the intercept and the slope and the slope. Use the name of the object itself and then the dollar sign. Okay, so for example, I can get the head, head class, diba? Those are the first 6 observations in default. Mod 1 and then dollar. Okay, I want to get the residuals there. And then, so this will give us the first 6 observations. If I just want the first 4, I identify 4, control enter. It will give us the first 4 observations. Okay? All right, then this is very important, the summary function. So let's take a look at this. We'll spend the rest of the time looking at this, the result of this function. Summary mod 1. So let's run this class. All right, so we have quite a huge, not huge, but relatively big output here. All right, kindly chat first, please, if you got the summary function. I'd like to, okay. Kindly chat yes if you got this output here. Okay, waiting for the rest to give their feedback. Okay, only 7 out of 25. How about the others? I hope you're able to follow along. If in any time during this discussion you feel lost and some code is not clear to you, please do not hesitate to ask. Okay, so class. So let's take a look at the result of the summary. All right, first here you have, this is the call. It tells us what formula did we use. So we use the LM function, and the formula is hourly wage regression education data is equal to age. So it tells us the formula that we used. And then here we have residuals. So you notice it tells us what's the lowest among the residuals, what's the lowest value, and what's the highest value, 16.6085. And then we can actually check that. So let me see. Let me clear the drawings. All right, here we can get the minimum of, and I want to get the residuals, mod 1 dollar residuals there. Okay, so this will give us the minimum, and then let's also get the maximum mod 1 dollar residuals. So you can access class, very easy for us to access any data point there. All right, so if I run this, what do you have? Negative 5.33, 34, and 16.6. So let me run this again. Okay, negative 5.34, 16.6. Yeah, you got it, class. So we were able to get this from the mod 1 function. All right, then take a look at this class. You now have this, the coefficients. Remember, class, that why are we doing regression? The main purpose is for us to create a model associating your hourly wage with your independent variables. In this case, our hourly wage is our dependent variable, and since we're doing only simple linear regression, we have one independent variable, which happens to be education. So here it is, class, here. This is our intercept. This is your beta null, or beta, or B0, and this is your independent variable education, beta 1. And the equation here is, these are your parameters, okay? So your hourly wage, let me use hourly wage. is equal to sub I, because there are several observations, that's negative 0.90, okay, plus, I'll just drop it to 2 decimal places, 0.54, okay, never mind the rounding off class, times education, sub I. Okay, if you want this to be equal, then this should be hat, or I can just create here an epsilon sub I. Okay, or once again, if I want this deleted, I will have to put this, and then that's it, because we don't put a hat to education, because education is not predicted. Okay, and this is the equation now. Okay, so let's interpret this. What is the meaning of negative 0.90 plus? What's the meaning of the slope here? By definition, the slope class is what? It's what? It's the value. It's the value class of what? This one is the value of your dependent variable when all your independent variables are equal to 0. So even if we have several independent variables, okay, so when all of them are equated to 0, for example, if education is equal to 0, then of course this will cancel out, right? Because 0.54, no matter what the value of your slope, multiplied that by 0 years of education, this will become 0. And what will be left is your intercept. So your intercept is the value of your dependent variable hourly wage when all your independent variables are equal to 0. Now take note that we don't put so much physical interpretation of the intercept. Okay, why? Because in this case, for example, negative 0.9 hourly wage. Is it possible to have a negative hourly wage? It means that the employee will be the one to pay the company kasi negative 0.9 siya, hourly wage niya, di ba? So doesn't make a sense. Okay, but let's take a look at this class. Standard error, we're going to study this next time, and the t-value, this is the t-stat, okay, that's used here, and then we have here the p-value. The p-value is 0.187. Now take note, there are no stars here. So remember, class, we discussed that if there are 3 stars, just like this, in R, this is significant at the 0.1% level of significance. So very highly significant siya. If there are 2 stars, then this is significant at the 1% level of significance. If there's 1 star, then it's significant at 5%. If it's a dot, sometimes you'll see a dot here. So for example, you might see a dot here. Here, for example, example only. If there's a dot here, it means this is significant at 10%. If no star, no dot, it means that it's not significant, not even at 10%. Okay, so this one, class, your p-value is greater than your level of significance, which is usually 5%. So 18.7% is greater than 5%. Now, this class is an inferential statistic, which means that you're testing something here. No? Meron tayong null hypothesis dito. Ang null hypothesis natin dito, null 1, because you have 2 hypotheses, is that your beta null, your intercept is equal to 0. Okay? That's your null hypothesis. Of course, your alternative hypothesis HA1 is beta null is not equal to 0. Okay. Now, what's our inference now? So you take a look at your p-value. If your p-value is greater than the level of significance, and oftentimes it's 5%, unless in some cases where it can be different. If it's greater than 5%, then what happens is that we reject. Okay, we reject. Okay, so sorry. If it's greater than 5%, then we fail to reject the null hypothesis. Okay, the rule is, what's the rule? So that you can remember, if the P is low, the P value, the null must go. Okay? If the P is low, the null must go. When you say low class, lower than the level of significance, which in this case is 5%. Okay, if the P is low, the null must go. So in this case, the P is not low. So we cannot, the null must go means we cannot reject the null hypothesis. So our conclusion, our inference is that we failed to reject the null hypothesis. We did not find any evidence that your intercept is we did not find any evidence that the intercept is not equal to 0. Okay, we reject, we fail to we fail to reject the null hypothesis. Hindi tayo nakita ng evidence class na ang beta null is not equal to 0. All right, so that's what that means. Okay, so ano ibig sabihin nito? So sabi niya na yung beta null, kasi na-fail to reject natin na beta null is equal to 0, then it should be equal to 0. So technically, class, theoretically, the intercept should be equal to 0. However, class, okay, ang practice class, si intercept kahit si slope kahit na hindi siya significant, it's always included in the model. Okay? Okay, take note class, no? Sabihin natin ang si education ang 0.187. So ibig sabihin nun, si education, we fail to reject the null hypothesis that education is equal to 0. So ang mangyayari niyang class, 0 sa education, mawawala to. So si 0.54 na to, hindi pa pwede to kasi statistically, statistically yung intercept, yung slope ng education is equal to 0. Okay? So this will not be included sa equation. But for the intercept, even if it's not statistically significant, then it is still it's still included in the model. Okay, let's go here. This time, education class, 0.54. And the T-stat is 10.167. May cutoff yung class. 1 point something, no? 9 something, para maging significant siya. And then ito class, take a look at this. It's highly significant. It's written in scientific notation. 2 times e to the negative 16. So what does that mean? Negative 16, ibig sabihin yun, 0. Okay? Maglalagay ka ng 15 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then put the 2 there, 2. There. So the value of this plus this p-value is practically 0. So going back to this rule, if the P is low, less than 0.05, the null must go. So ano ba yung null natin dito sa education? The null hypothesis is H2. 2 not 2 kasi yung unang slope is that beta 1. Beta 1 siya, no? Ang intercept ang beta 0. Beta 1 is equal to 0. Okay, anong conclusion natin? The p-value is practically 0, less than 0.05. So conclusion, we reject the null hypothesis that beta 1 is equal to 0. Reject natin yan. There's strong statistical reason to believe that your education slope is a value sorry, not equal to 0. In fact, the average is 0.54. So, yung equation natin, yung model natin, pasok to, no? Yung 0.54 times education. Kasi statistically significant tong beta 1 natin to. Because it's the p-value is practically 0, no? And it's greater than it's less than 0.05. Okay. So, andito class yung codes, ha? Itong 3 stars, andito siya, 0.001 or 0.1%, 2 stars, sa Arto, no? Sa ibang software, iba yung ano nila, notation. 0.01 or this is 1%, 1 star is 0.05 or 5%, and then ito yung dot na sinasabi ko, class, dot, no? The dot here means that it's significant at 10%. So depende sa study natin, if you're letting the significance level be 10%, then significant yung pag may dot. Okay, let me pause for a while. Any questions so far? Any questions, class? Sabihin na lang, clear so far, pa yes or no na lang. Thank you, Dan. About the others, clear ba tayo so far, class? Okay, thank you. Adi, thank you. Okay. Orly. Okay, Veronica. And I hope the others are able to follow. Okay, wala na mag-respond, class, sa question. Anyone who has questions, class? So may tanong dito, how do you specify, Gab, how do you specify which observation po for the coefficient? What do you mean, Gab? Sorry, hindi ko nakuha. What do you mean by how do you specify which observation for the coefficients? If you want y sub 2. What's y sub 2? Yung second observation, third observation? Is that what you mean? Okay, sige. Thank you for that question. That's a very good question, Gab. Sige, puntahan natin yan. Actually, pa-discuss na ako niyan. No? So let me first clear my drawings and then X here. By the way, there are still some things here. Okay. This one, class. Okay. Okay, actually, class, so ito yung ano, no? Ang tawag natin dito, these are your, okay. Let me go back here to annotate. Ito, class, itong test nito, this is the individual, no? Individual tests of your parameters. Individual siya. Okay. This is, it means that your null hypothesis for your slope is this one. Separate siya. Your null hypothesis for your mean, for your intercept and then slope. So separate yung mga hypothesis na yan. Now, you're actually doing also another joint test, which is the analysis of variance. May test pa nun, ano? Tapos ang null hypothesis niya, another test here is that beta null is equal to beta 1 is equal to beta 2 is equal to etc. Since dalawa lang tayo, no? Beta null, beta 1, wala naman tayong beta 2 is equal to 0. So this is another test. This is your analysis of variance, ANOVA. No? Or this is the joint test. Joint test kasi pareho natin tinitest si beta null at saka beta 1. All right, in order to do that, class, okay, ito ang ginamit natin t-test, no? Ito naman f-test. Sa f-test, class, dalawang degrees of freedom. Ito, tinan nyo. F-stat, yan, no? On degree of freedom 1 and degree of freedom 2. Okay, so what's the degree of freedom 1? Just a brief review of your stat. Degree of freedom 1 is your number of parameters, number of predictors. So ilan ba yung predictors natin, class? Si education lang, di ba? So 1 yun. Yan, kaya 1. No? If there were 5 predictors, magiging 5 yan. Okay, and then this degree of freedom 2, that's equal to n minus k minus 1. The n is the number of observations. The k is the number of your predictors. Okay, ilan ba yung n natin? Ilan yung observations? 526. Ilan yung k natin? K is 1 kasi isa lang yung predictor natin. and then may minus 1 pa. 526 minus 1 minus 1, you get 524. Okay, saan ginagamit to, class? It is important, it is needed in determining the value of your F-stat. Pero hindi naman tayo, class, we will not go back to the your basic stat na given the degree of freedom 1, degree of freedom 2, hanapin yung F-stat value. We're not going to do that. So we'll just assume na alam natin kunin yun, tapos ibibigay sa ating p-value. Alright, so ito, class, kaya ang sabi dito, degree of freedom 1, 1, degree of freedom 2, 524, F-stat is 103.4, and the corresponding value of your P is parang pareho din ng isa kanina, no? So it's 0.00345, etc. hanggang 15, tapos 22. Kasi 2.2 siya. Yan. So ito yung p-value nito. Therefore, anong inference natin dito? The p-value is much, much lower than 0.05. Therefore, we reject the null hypothesis that beta null is equal to beta 1 is equal to 0. Okay, we're rejecting that all of your parameters is equal to 0. At least one of this is not equal to 0. And we know that what is not equal to 0 is actually beta 1. Okay, so we'll discuss this in greater detail just for you, but it's important for us to understand really what's happening here. Okay. Okay, residual standard error is simply just like the standard deviation of your error. Okay, and we know this 524 degrees of freedom, that's your DF2. Okay, how about this multiple R squared? Ano ibig sabihin nito? Multiple R squared, 16.48, and then we have 16.32. Okay, ano ibig sabihin ng 16.48? Okay, so we have here your hourly wage, diba? And it tells us that around 16%, no? Sabi natin ito. This is 16% of the variation of your hourly wage can be explained by education. Okay? So sa education, kaya niyang i-explain yung 16.48% ng variability ni hourly wage. So medyo mababa to, no? Kasi ang kaya lang niya 16.48. Ibig sabihin, meron pang ibang variables na kayang i-explain si hourly wage. Okay, and then we're going to that next meeting. 16 lang. Ibig sabihin niya, this is your explained variance. Explained variance siya. Na-explain, no? And this one, this 83 something percent is your unexplained variance. So paano siya may explain? Well, you might need to use other variables in order to explain. Kasi ang kaya lang i-explain ni education yung 16.48%. Yung adjusted R squared, class, i-discuss natin to next time kasi this is all about, so ito, no? Ito, class, this is your, okay, nawawala na naman tong ano ko. R squared, ito. R squared yan, no? Capital R squared. Okay, yung isa naman, R squared adjusted, ADJ, ito. And it's usually lower than your R squared. I'm going to discuss this and using my dash, my bar dyan, no? We're going to discuss this, class. Ano ibig sabihin ng 16.32 na yan? All right, so I hope clear to so far, no? So let me continue. Okay, so let me go here. Okay, ito na yung tinatanong kanina ni ni Gab. Okay, let me first go here. All right, let's use this, class. Generate this object. So we're creating this object called mod1.receive. Gagamitin natin si broom, class, broom package. So si broom package, class, and then there's this function called augment, no? Augment model1. Okay, kindly run this, class, no? Kindly take a look at what happens. What is the object that's generated when you run this mod.1 receive, and then broom package, and then we use the augment dataset, augment function, I mean. So control enter, and then what happens is that I get here, I hope you're following along. I get here an object called mod1.receive, and it's a data frame. consisting of 526 observations and 8 variables. Now, I'd like to use this to answer the question of Gab a while ago. No? Okay. So do you have it, please? Kindly chat, please, if you have the object mod1.receive. You have the object. Kindly chat, please. Chat yes, if you have it. Or no, if you're having problems getting it. Okay, thank you. Thank you, Carlos. How about the others, please? Okay, thank you, Sam. Adi, thank you. All right, Dan, thank you. Okay, I hope the others are following along. All right, so let's print this class. Okay, take a look at this class. No? There are several inputs here. Number one, class, we have hourly wage. This is the observed value. This can be found in your wage data set, di ba? Ito sa wage data set natin, 3.10, no? 3.10. So, 3.10, 11 yung education. So, dito sa mod 1.receive, naka-identify class yung dependent variable hourly wage and your independent variable. Okay? Then we have this one, no? We have the fitted value. Ano yung fitted value, class? Your fitted value is also the same as your predicted value. So, itest nga natin, class. I'm going to copy this. Sorry, fitted value is so Control C. Let me go here. Dito na lang, sorry. So, how do we get the fitted value, class? Let's get the mod 1 mod 1 coefficients. No? Okay. Ito yung mod 1 coefficient. Let me copy this. Control C, Control V. All right. So this is the intercept, 0.9045. And then I'm going to add plus, plus. So the slope times education. What's education? For observation 1, the education is times 11. All right. So now we're performing the equation, right? The regression model. So this is the intercept plus the value of your beta 1 times the value of education. If we run this, class, Control Enter, I get 5.050101 there. So that's your predicted value. That's your fitted value. Okay. And then to get the residual, Control C, Control V, you have your observed value minus your predicted value, Control C, Control V. Okay. So observed value, actual value minus your predicted value, this gives you your residual, this one, class. Negative 1.95. All right, negative 1.95. Okay, so let's go to the next question. Yung kay ano, yung question ni Gab. Control C, Control V. What about the second observation? Tingnan natin, class, ha? Yung second observation naman. So this is your intercept. It's the same regardless of your remember, class, yung intercept, it's the same regardless of your observation. Intercept yan for the whole model yan. And then this is your your slope. Multiply that by, what do I multiply that by, Gab? What do I multiply that by? Yes, correct. 12. No, bakit 12? Kasi ang tinitingnan natin ngayon is the second observation times 12. Okay, so let me put here times 12. And let's see what will be the fitted value or predicted value. Control Enter. 5.59. Ito yun, no? Diba? So this is okay. Tama to. And then if we're going to get the residuals, 3.24, Control C. The actual value, Control 3.24 minus the predicted value, Control C, Control V. Okay, subtract, and then you get negative 0.23. There you go. Okay. So Gab, did that answer your question? Okay, so we can go anywhere here, class, and we can prove that the values the values here are okay. So there are other variables here, class. Yung dot hat na to, this is not the predicted value. Kasi baka isipin nyo, ay hat value yan, di ba predicted yan? No. Iba yung augment. Yung dot hat na yan, we will discuss that later on. This has something to do with the leverage values, no? Leverage. And I'll explain what a leverage is. And then ito, class, yung Cook's distance, ito yung influential data points. The higher the Cook's distance, the more possible that observation is an influential data point. Okay, let me just describe what, di ba yung sa ano natin, if you recall, class, si Tuki, yung ano niya, yung yung box plot niya, di ba, you can identify using box plot the outliers. So we have three types of data. You have actually four. Yung normal, quote unquote, then you have the outliers, then you have the leverage, and then you have the influential. Ang pinaka-critical dyan, class, is the influential. Okay? So not all outliers are influential data points. Bakit? Ano bang importance ng influential data points? Influential data points, class, are data points in such that they they have an impact on the parameters. What do I mean by that? Yung betas natin, beta null, beta 1 in our case. So pag influential yung data point na yan, pag tinanggal mo yan, class, pag tinanggal natin yan, then it may change drastically your beta null and your beta 1. Kaya ang tawag sa kanya influential. So i-discuss natin to later on as we go to diagnostics. So may mga influential data points, and does that mean na dapat tanggalin kagad yung influential? No. Ibig sabihin na nun, tingnan, baka may error sa pag-ano, or that should be explained, class, kung bakit naging influential yung data point na yun. Alright? So outlier, leverage, influential. Okay, all influential data points are outliers. Hindi siya maging pwedeng influential kung hindi siya outlier. But not all outliers are influential. So I hope you get the distinction. May mga outliers lang, pero hindi siya leverage, hindi siya influential. Pero lahat ng influential, outlier yan. Outlier siya. Alright, so we can actually create an object na just getting the first four. No? Okay, I also, ito, diniscuss namin kanina to. Okay, so in the interest of time, let's see. Okay, if you want to reduce the the number of the number of decimal places, kasi ito ang dami, no? 9 decimal places to. You can round it off. Okay, so let me just share this function with you. Ito na lang. Let's and then yun na lang din. You can use the round function. Can you try this, class, please? Okay. Round and then define natin 3 decimal places. And tell me, class, please, what you find, what you see. When you use the round function and you identify 3, what happened to your mod 1 that received? Okay, feedback, please. What did you get? Class? What are we getting there? Pag renound natin. Put the round and then dapat nasa loob yung comma 3 as around. Hello, class. Walang feedback? Yeah, thank you, Dan. So it rounded off the output to 3 decimal places. So, so if you want the output to be in 4 decimal places, you can use the round function. Okay, now let's go here. Let me share this with you, class. Okay, and let's take a look at this. Okay, pakirun to class and tell me what you see. Now, ggplot is a function of ggplot2. So either you get, if you haven't loaded ggplot2, okay, or you can just get the bigger package, which is tidyverse. Okay, so if I run, for example, tidyverse, because if you don't run tidyverse or ggplot2, the ggplot function will not run. Okay, so library gg tidyverse, and then hindi ko na-delete to. Okay. Let me rerun this. Kasi kanina may pending pa kanina. No? Hindi ko siya rinan. There. Okay, if you were loading this for the first time, when you open your R, may mga notes na nalalagay na kung ano yung mga kasama na packages. So I'm sure in your case, it did. So what other packages come with tidyverse? Hello, class? Okay, come on, class. We're wasting time. All right, I leave that question to you, class. Okay, let's now run this and see what happens. Before we run it, or if you have run it, let me just explain. So here we're creating a plot. It's a grammar of graphics plot, ggplot. This comes from the package ggplot2. And we're plotting, the data that we're using is mod1.recede. Okay, and we're identifying here the x and y axis. The x will be your education, and y will be your hourly wage. And then plus geom point. So here we're plotting, up to this point, we're plotting the scatter plot, the same as what we plotted a while ago. Okay, and then here we're adding stat smooth method is equal to lm. So we're adding here the regression line. Okay, we're adding here the regression line, and then plus geom segment means we're creating a segment. Okay, a segment where your x is from your education up to your your x is up to the end of education, and your y is up to your fitted. Your y will end at your fitted value. So if you run this class without really going much into the nitty-gritty details of your function, of your code, you have this class. You have this chart. You have this plot. Okay, so you can see here, the points here are your, these dots here are your observed values of your hourly wage and your education. They're your pairs, okay? Pairwise of your data. Then the blue here is your regression line. Okay, so that came from this one here. Stat smooth method is equal to lm. So that's your regression line. And then the segment here, so we told R to drop the segment from your actual data point to your regression line there. Okay, so you can see here. Okay, remember class, this is R, solve this with the method of least squares. So we can create the figure for your squares here, and then add it up, and this gives us your beta null and your beta 1. Okay. Gab, baka kailangan mong ano, no? Kailangan mong you might need to update yung ggplot2 mo, no? How about the others? Update mo lang si ggplot2. Makikita mo dito yan, no? Packages, and then here, ggplot2. Ayan. Okay, sabi dito, may version. 3.4.4 na yung latest. So here you can ano ba yung update dito? You can update the package. Not the R, the ggplot2. Yung ggplot2 yung update. Okay, so it's almost time, class. So let me just end in this. Para pareho lang kayo ng ano, no, ng ang kabilang section. Control C. Chat ko na lang. Okay, that one and this last one. Okay, I hope you don't mind me extending just a few minutes, class. But if you need to go, class, you may do so. Tapos ito pa. Of course, we won't be able to finish all of this now. But let me just discuss yung first one. Ito, class. Okay, we know that R generated for us. Yung first LaTeX that I gave you is this one. Okay, so let me just explain quickly. This, class, is the formula for your slope. So this is what's done by the model. So this one is your slope, class. This is your slope for variable 1, B1. And the complete formula is actually this one, n minus 1, and then this one divided by n minus 1. This is the complete formula. Now, it was canceled because they're the same. But I hope to recall in your basic stat that this is x minus x bar times y minus y bar, summation of that over n minus 1. This is actually your covariance. So that's your covariance of x and y. And on the other hand, this is your variance of x. Or xx, or another name to do it is variance of x. Right? Take note, class. Pag covariance, dalawang variable yan, ha? X, y. Covariance of x with x, walang square dito. Or you can write it sigma squared of x. Okay, so this is your formula. So alam ba natin yung mga x's? Yes. Alam ba natin yung average? Yes. Alam ba natin lahat ng mga observed y? Yes. Alam ba natin yung average ng y? Yes. Okay, so ito pareho lang to. X observed minus x average squared. This is your variance kasi, no? So below, class, I just gave you I leave you the formula, class, to compute, no? So I gave this, diba? So i-attach natin si wage para magamit natin yung directly yung mga variables yan. So I'm computing now for B1, okay? And it's just education. This is your x minus mean of education. This is your x bar times this is your y. Hourly wage minus the mean of hourly wage. This is your x y bar. And then divided by educ x minus minus average of x squared. So that's it, class. That's it. This is the formula for your B1 or your intercept. Okay. If you run this, so nag-attach ako, tapos nag-detach ako para ma-run natin to. Okay, if I run this, I should be getting 0.5413593, which is, if I get mod 1 dollar coefficients and then coefficients, and then I just get the second one. Okay, sorry. And then I'll just get the second coefficient, 2. Okay, kasi di ba dalawang coefficient? All right, so ang B1 natin, which is the slope, is 0.541 according to our formula, according to this formula. And then if I get it from the output, okay, mod 1 pala, sorry. Mod 1, up, and then mod 1, coefficients, and then the second one, kasi dalawa yan eh. Yan, 0.541. Parehong-pareho class. Okay, so that will be all for today. Let me stop recording.